this example, we want to find the values of c for which the graph of y equals x cubed minus 3x squared plus c crosses the x-axis 3 times. Okay, on a calculator page, let's define the function. So to define a function, we go Menu, Actions, Define. I'll call the function f1 of x because I will then graph it later on. So type in x cubed, remember to press the arrow to get out of the power, minus 3 times x squared plus c. Alright, now the turning points are the important part here, so we want to differentiate the function. Okay, so to differentiate the function, there are a number of ways. One way I like to do it is to hit this little template next to the book command. You can see that d by dx is highlighted there, so we'll just press enter, type in the x there, because that's the variable we're differentiating with respect to, and now we have to type in the function f1 of x, which is already defined, so we can press the var command, and all we have to do is insert the x and press enter. So that's the gradient function, 3x squared minus 6x. What we want to do now is solve and find the turning points. So to do that, we're going to go Menu, Algebra, Solve, and we want to solve where the gradient, well, we could type that in. Alternatively, just press the up arrow command and solve when that is equal to 0 for x. So we type comma x. That gives me x equals 0 and x equals 2 as the two x values of the turning point. Okay, so to find the y value, which will obviously depend upon c, we want to substitute in those two values. So let's press the var command and type in 0. So the y coordinate when x is 0 is c. And let's find out now by reissuing that command what the y coordinate is when x is equal to 2. So this one is c minus 4. Okay, so looks like c equals 0, c equals 4 are some critical values here. So let's now evaluate and perhaps find out how many roots we've got. To do that, we want to go Solve. So Menu, Algebra, Solve. We want to solve where f1 of x is equal to 0 for x for some typical values of c here. So I'll use the given command, Control equals. And notice that I can press the left arrow to jump backwards straight to that one. Alright, so c equals 0, c equals 4 seem to be critical values here. So when c is equal to 0, I get 2 values. What about when c is equal to 4? Again, I get 2 values where it crosses the x-axis. But this is basically a trial and error method. Let's try c equals 4.1. I only get 1 value. What about when c equals 3.9? Here I'm getting 3 values. What about when c was, say, 0.1? Again, I'm getting 3 values. But if c equals minus 0.1, I'm only getting the 1 value. So it appears that this graph crosses the x-axis 3 times when c is between 0 and 4. Now, that's just one way of doing it. It was sort of a bit of trial and error method, but we can also see this graphically as well. So let's insert a graphs page here. And because the function f1 of x is already defined, I've got a slider which automatically appears for c. Now, we can see that when c is equal to 3, this graph is crossing the x-axis 3 times. However, if I move the slider, we can see that when c equals 4, it's crossing once and touching once. However, if c is equal to 5, it only crosses the x-axis once. Now, for c between 0 and 4, it's crossing 3 times, but when c is equal to 0, again it crosses once and touches once, but when c is smaller than 0, say -1, the graph is only crossing the x-axis once. So I think this is a very good visual aspect to see how many times this value, or the value of x, for which the graph crosses the x-axis, 0, 1, or 2, or 3 times. And if you think the value of c is just a translation parallel to the y-axis, which affects how many times this graph will cross the x-axis according to the y values also of the turning points as well.